Last week we discussed about the NOT gate, then AND gate, OR gate. Okay. So now look at this one. If we input A, then the output will be Z. So if it is a NOT gate, then output will be A bar. If the input is A, then the output should be A bar. If input is A and B, if it is going through AND gate, then the P is output. So P output should be A dot B. That means A and B. Then the last one, OR gate. If we are inputting input A and B, then if it is go through OR gate functioning like a addition. So the output should be A plus B. Just look at this one. A input, the output is P. What is the output? A bar. P should be A bar. If it is going through NOT gate, then output should be P bar. So Q should be P bar. So if I write P bar equal Q, then instead of P bar, I can write P mean A bar. So A bar bar, two bars are there. So if there are two bars, two negatives, that means it will be positive. There will be a rule. Later we will discuss that one. Just imagine -1 multiplied by -1. Obviously, it becoming +1. So likewise, A bar bar. That means the value will be A. Then this one, if we get X input and output is X bar for the NOT gate, then here we have Y. Then X bar and Y is going through the AND gate. Then output Z should be X bar dot Y. So when you are doing this kind of question, take branch by branch. Straight away don't write the answers, okay? So each branch, each path should consist of the value. So each output should be displayed as there. Okay, so otherwise you will lose the marks. So if this is input X, then the output of the NOT gate must be written there. Okay, so if they haven't given any variable for the output, you better mention it on the output line. Then you will get the score. Okay, so I think this is clear. The X bar and Y are input for this AND gate. Then output will be X bar dot Y. Then I just keep on explaining. Then after that, I'll ask you to do this one. If there is A input going through the NOT gate, output will be A bar. If there input B going through the NOT gate, output will be B bar. So this A bar and B bar going through another AND gate. So AND gate is functioning like a multiplication. Then F is equal to A bar dot B bar. Why? AND gate is a multiplication. So input for the AND gate is A bar and the B bar. So A bar dot B bar will be the output of F. Okay, so this one. A input, output will be X, Y output. So Y will be A bar, bar. Two bars, then it will be A. Third one also. This is not, we have done these three, not in this part. Yeah, we'll complete up to this one or in this slide. After this slide, you better complete. Okay, so I'll erase the output. You have to, not only this, we have done this one. So these two, I will erase the outputs. You must find out the output of all those. Shall we start doing this? No, this is, I think we can. Hold on. This 1, yeah, 1. First one, okay. Second one, there was 1. Third is similar. Third, no need. Only the third one will remain. Okay. So I'll number it from the beginning. 1. Copy down this one again, then you can remember the function. This is the first one, then second one, third one. Then we will take this one as fourth, and this is fifth one. And here I'll take this one as sixth, and this is the seventh one. Shall we start it? I'll erase the outputs. First two, okay. The second one, I'll erase the output. You must do it. Okay, copy this and this and this. These 3 slides. Quickly copy down. After copying up to question number 7, then copy down these 3 questions, 8th, 9th, and 10th. Okay, copy and find out the answer. Okay, now look at, we are taking the input A. A is going through the NOT gate. So therefore, the output of A should be A bar. Then B input is going through AND gate. So the inputs for the AND gate is A bar and B. Then output should be A bar. Did I write the variable for the output? No, ne? So output should be A bar dot B. Then assume that output is Z. Z output equal A bar dot B bar. Then next one, A input, B opposite of B is B bar. Then going through AND gate, then output should be A dot B bar. 10th one, P going through AND gate, NOT gate, output should be P bar. Q going through NOT gate, output should be Q bar. So those two are going through another AND gate, that is multiplication, P bar dot Q bar. Going through the NOT gate, output will be R. Then it should be P bar dot Q bar dot, that means multiplication, over bar. Why? Then this is a NOT gate. Therefore, it is giving the over bar. Then we'll start doing the question. Next one, 8th, this one, 11 and 12, 13. 11, 12, and 13. Okay, copy down and find out the answers. And send me the answers to the chat. Okay, so if the P is input for the NOT gate, then output should be P bar. Don't miss any output, write everything. Okay, if the P bar is input for the NOT gate, then output should be P bar bar. 2 bars are there. You know that if there are 2 opposite, that means it is equal to the P. If there are 2 opposite, it is equal to the P. Then if it is going through the NOT gate, that means it is P bar. What do you mean by that? There are 3 NOT gates. That means P bar bar bar. Okay. So as we know, if there are 2 bars, that is equal to P. And there's another 1 bar. Okay. Then this one, multiplication for these two. Therefore, P dot Q will be there. Then F will be the NOT gate of the P dot Q. Okay. Then here, OR gate working like addition. A plus B, then output will be F equal to A plus B over bar. Actually, I think you know these two. What are those? What is the name of this gate? This is what? And no, not mean. We call it as not, and not mean. We call it as what? NAND gate. Okay, this gate we call as NAND gate. In and. Okay, the gate name is NAND gate. Then look at the next one. O and not gate. O and not gate mean we can draw this one as no gate. Okay, there's a not. Then we can write the output of not gate. No gate, output of no gate as this one. A plus B over bar. Okay. So next topic is NAND gate and NOR gate. We will discuss that. Okay, so we'll move to the question number 14 and 12, 13. Okay, 13, 14 and 15. 14th one, we have the NOT gate. So R bar will be the input of this one. Then output will be R bar dot S. Then if it is going through another NOT, R bar dot S again over bar. So normally if there is over bar, we are in the brackets. Okay. So since there is a multiplication, we are writing with the over bar. Here B bar, A dot B bar multiplication Z equal to A dot B bar and the another not gate over bar. You can put the brackets there even. If it is not there, even no issue, but normally we are putting the bracket. So if there's a plus, keep in mind, normally put in the brackets. Multiplication is not the must. Okay. Okay. Now we are moving to the NAND gate and NOR gate. Before that, check your answers if there anything to copy down. Quickly copy down it. Okay. Okay. Let's move to the other combinational gates. So combination, first I'll explain and I'll let you to write the notes later. Combinational gates mean joining main gates. So what are the main gates? The basic logic gates, AND gate, OR gate, and NOT gate. These three are the basic logic gates. So if the basic logic gates are combining with another gate, combining together, if logic gates are combined together, we call as combinational logic gates. So mainly combination logic gates, we are taking NAND gate, then NOR gate, XOR gate. Okay, so mainly three types we will discuss. Look at this one. NAND gate is a digital electronic NAND gate, not AND. So NAND gate we are writing with the not and the AND gate. NAND gate we write with the not and NAND. Is a logic gate which produce the false, is a logic gate which produce false output, which is false only if all the inputs are true. Actually, it is the opposite of that, an AND gate. Okay, so if we write the multiplication of S1 and S2 inputs, just assume S1, S2. I think it is easy for you if I draw this one with I'll erase this one. Okay, I will take L later. My input are S and S1 and S2. So think my input, I'm going to, actually this is working like what? S1 input, S2 input. Okay, there is AND gate. Then I'll take this one as X. This X is going through another NOT gate. Okay, AND gate, output going through the NOT gate. Think that is the L. So now I'm going to find out the X. X is mean 2, S1 and S2. So these two should be multiplication. So X equal to what? S1 dot S2. Then 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. So opposite of X is L. Okay. So I can write it with this. If I take L in green color, it is equal to opposite of X. Okay. So I'll take the L. So L means 1, 1, 1. Output will be 0. So actually, what is the output we need? We need the L output. Ne? So straight away, we got that output. This is the what we are looking for. We can't directly write. We'll write one by one. No issue. So S1, S2 is there. Output is L. So output is coming with this one. So now look at the note what explained here. NAND gate is not an AND. So AND gate output is going through the NOT gate. It's a logic gate which produces a false output, which is only if all inputs are true. That is very important. It produces the false output when if all the inputs are true. හැම එකක්ම true වෙනකොට ඔන්න වෙනකොට එයා false output. If both the inputs are true, it will give us the false output. So now look at the Boolean expression. Okay. So we should write entire slide. You have to copy. Just look at the gate switch. It is working like this way. I'll take a new slide and write. So no gate output. Sorry, NAND gate. NAND gate output actually, as I said, and not. So and not mean unit on the circuit, this one. So we have the A, B switches and there is a bulb. I'll draw it here. If we have S1, according to our question, S1 switch and S2 switch. Okay. And there is the battery. So the bulb is on top of this like a parallel circuit. So bulb means I have the output L bulb. So when I switch on S1, the bulb is not. Bulb is lighting. Why? Current can pass from this direction. This is open. If this is open, bulb is not. Bulb is lighting. If this is closed and this one open, bulb is lighting. This path is open. If both the paths are closed, then only bulb is switch off. Okay. So to switch off the bulb, both the path S1 and S2 has to be on. When S1 and S2 on, bulb is switch on like this. When S1 and S2 on, bulb is switch off. Here, S1 and S2 on mean මේ පාර අර යන්න පුළුවන් current එක යන්න පුළුවන් වෙලා තියෙන්නේ මේ අතර. So when the current can pass through S1 and S2, then bulb is switch off. Okay, මෙයා on නම් මෙයාත් on. If these two are on, then bulb will off. හරි. ඒතර on off කියන mode දෙක අපි check කරන්නයි යන්නේ. Off කියන්නේ ඇරලා නම්. හරි. So on mean 1, that mean close. Off mean open, that means 0. Shall we draw this circuit and this diagram, copy down this one NAND gate, then copy this circuit diagram as well. Okay, quickly copy this slide.